Thank you so much, Madeleine. I'm excited to be moderating this panel, and with me I have Chris from NASA and Michael from AddUp. Let me just kick things up. So, is to infinity and beyond, and how we actually gonna have AM leading the way to live amongst the stars. So for this panel being the last one, when I think of the to infinity and beyond, I can't help thinking of Buzz Lightyear from Toy Stories. So this conversation is going to be about being brave, being bold, and think about how AM could look like in 30 to 50 years, and how we're actually going to be living amongst the stars, and how we're actually going to eat, sleep, and live and work in outer space. So I hope you get inspired. We're going to do a quick intro, because I think the best way to get to know our panelists is they introduce themselves. We're going to do a quick intro, and then we're going to go through some questions that we have addressed and want to bring up. And then we want to make sure we leave 12 to 15 minutes for the audience to ask questions. So Chris, tell us a little bit. So everybody have about 3-4 minutes. Tell us about yourself and your thinking about space.
All right, thank you, Tuan. I'm happy to be here, and thanks for the invite here today. I'm Chris Protts. I'm the technical lead for advanced manufacturing in the Materials and Processing Laboratory here at the NASA Marshall Space Flight Center down in Huntsville, Alabama. And so our lab provides engineering support to NASA partnered activities and in-house activities that advance our mission across a wide range of capabilities. So we cover metals, polymers, and composites, and ceramics. We also cover processing and joining, additive manufacturing processes, including laser powder bed fusion and directed energy deposition, materials testing and microstructure, and integrated computational materials engineering, fatigue and fracture control, and NDE. And last but not least, here, space environmental effects here, a topic of relevance here today. A bit of my background. So after completing my graduate work involving microelectromechanical systems for rocket propulsion applications, I joined NASA, and I worked in the liquid rocket engine combustion devices area and in propulsion systems. My work over the last 5 to 10 years has been pretty heavy in the application and testing of advanced and additive manufacturing technologies, including laser powder bed fusion of copper alloys for thrust chambers and composites for high specific strength jackets for chambers as well in those areas of propulsion. So that work had led me to expand my current role in NASA, covering a wider range of advanced manufacturing, covering across the gamut from composites to large scale advanced manufacturing, digital thread. And today we'll talk some of those areas where I see those can help NASA's mission, and where partner and NASA capabilities can combine to enable those missions here. Tuan said that this is at the last session of the day. He wanted it to be interesting, and so this should be kind of a free thinking one. So you'll hear some of the activities that we currently have ongoing, but there will be a lot of I think free thinking in the discussion too. So kind of getting out there. So the opinions today are my own, but they leverage the great work of many across NASA and our partners in these areas here. So thank you.
Michael?
Thanks, Chris. Hello, everybody. So first of all, I'm really happy to be today from France, and to be able to discuss about these interesting topics. So from my side, I'm Michael, key account manager for AddUp, a Michelin and Philippe company, a 3D printing company. Well, we prepare the thinking for space, and Tuan, you asked us to give our insight about this journey. I mean, projecting ourselves 30 years in the future, and of course 3D printing will play a really key point for colonization. And actually we've been part of the team. We built the first 3D printing machine that we will send to the ISS, because we know all that it will be the future. I mean, we need to print a new world. I mean, this is a topic of the day. I don't want to make a long presentation, because I think we need to go inside the topic, because it's very interesting. And well, thanks for starting, and looking forward to discuss with you guys question that we prepare.
Thank you, Michael. My name is Tuan Tranphan, and I love 3D printing. I've been in 3D printing for 19 years. I started with 10 years in polymer with Z Corp and Stratasys. Fell in love with the potential of metals. Joined Swedish art with electron beam, trying to print metals using electron beam in a vacuum. Joined a small company called Desktop Metal and worked with Rick Fulop and to build that up. Really learn about metals and pushing metal binder jetting, only to realize that I really don't know much about composites and really pushing polymer to mass production. So I joined Avivo doing unibody bike frames that was happening. I'm currently the Chief Revenue Officer at Azul. We're in Chicago, Northwestern spinoff. We're really a materials company. We are using our own proprietary, as the only one on this planet, who's using DLP with a liquid cooling interface layer, which enables us to go really fast through 3D printing and do big parts. So back to the topic. So now that we have the introduction, let's start with cutting it in different sections. How do we get out of this planet? How do we get into space? And then we talk about space and then how we're going to live there and how we're going to come back. So first question is, so what are the technologies? What are we thinking of? How do we getting out of into space currently? Chris?
Sure. And I think, if we watched some of the panel talks earlier today, we had some talks on propulsion applications, and for propulsion vehicles, I think that's an area where you've already seen the impact that advanced and additive manufacturing has had here. So you look at areas, and I mentioned some of my background in laser powder bed fusion for thrust chambers and for going to DED for nozzle work. These are some of the highest costs and longest lead items in propulsion applications. And now we're cutting down the timeline for those. So by reducing costs for that, we can make those models more sustainable and enable more people to send more things into space. I think, that's kind of the status of where we are, where the big impacts are, is additive helping us get us out of the gravity well. And I'll say another thing that some people mentioned earlier, I think in one of the other panels, is the ability for new entrants to get in there and new space companies. So previously, I think the HIP furnace was an example of large infrastructure needed, and these are barriers to entry for firms that want to innovate and build. And now additive, I think that's one area where in propulsion applications you're seeing it now in engines and you see it in vehicles, and that enables people to really join in and implement their ideas rapidly here. At NASA, we look to help bridge those gaps in technologies, taking it from low TRL efforts up into 5 or 6 where it's been demonstrated in environment, and then we hope to infuse it in the commercial side. So that's part of our goal, is really we want to be users on the commercial side down the road, and that's why we get into technology here.
Michael, you have anything to add to that?
Yep, sure. Well, for me, the first part is to think about that those resources, we need to think about right cycle. Everything we will do for 3D printing, we need to think about right cycle, because we are building the new world. So based on that, for the beginning, for metallic printing, because this is my field, I think we can start with wire. I mean, GG and wire could be the technology to build huge parts, maybe to build houses. Powder bed could be used for structural parts or for fine shapes. That we need complexity. Maybe powder bed could be a solution, but we have this microgravity issue to solve first. But why not? The second point is that we need to align what we will use regularly for whatever to the 3D printing on the local resources. We need to find a way to print something that we can find in Mars or on the moon. So we need to work intensively on this point. And looking globally, I think, and let's start to dream, we need to think about print organic stuff, print food more and more, but maybe medicine. We need to really develop organic printing. I think this is the trend for 3D printing on the space.
Okay.
Dreaming. This is a day dreaming. So just thinking maybe it could be the direction.
Okay. Thanks, Michael. Well, in short, in preparation for this panel, if you do a lot of research, you'll find a lot of space articles. It's really about how we going to do rockets and satellites and how are we going to get out of this planet, but very little about actually what is going to take to live on Mars, or what NASA is trying to do with the Artemis program on going back to the moon. So let's focus on living amongst the stars, living between planets. How are we going to live there? So let's start with that point. So where are we going to live? We have mega dust storm everywhere. There's the weather, the climate, everything is different, and we're really not that protected from the sun. So thoughts, Chris, how are we going to live on, let's focus on Mars as an example. What are your thoughts on that?
Sure. I think there's this kind of a standard path of progression as you look at that. So we have habitats in space. You have International Space Station right now, so we need to travel there. So that's what we discussed, kind of the getting off of Earth, and then you need transit to there. And so those habitats are, in a sense, usable as kind of short-term habitation, and habitats, versus housing. I think we call it habitats here on the NASA side. So you can look at, the initial level of that, which are largely aluminum. You consider composites there. I think longer term, though, and where we want to be is the ability to build housing on the surface, so on the site. So using what's available for resources there. And so both Moon and the Mars have dust and have composition of materials here. So when you start to think, like, for me on that side, you look at, well, we can use regolith as it exists right here. And so there's work in NASA that's been going on for additive construction for concrete, for lunar surface construction, extensible to Mars for sure. So building concrete structures, and not just housing, but pads and infrastructure to help enable the housing and life among Mars there on that side. And different technologies there for doing that. And additive is a large part in a lot of those. So you can go microwave and sinter materials to make a pad for a house, and then printed concrete. I was just reading the other day that GE is using it for windmill bases here. They want to start to build concrete bases on site on Earth for windmills. So before you correct me, I know the windmill is probably not the most lunar-based application for power generation, but extensibility of building concrete structures like that for sure on that side. And then I think longer term, we get into the ability to separate out. And I think we'll hopefully touch on materials and other things later, but as you can divide out components of regolith and dust from Mars and other areas, and then we can start to get back into materials that look more like we use at home, not necessarily exactly, but stripping it down into aluminum, silicon, iron components on that side. And then last part of that, you mentioned Mars, so we have carbon dioxide in the atmosphere there, a ready source of carbon for creating polymers and building things. And I'll just say on the last part of that, for housing at NASA and our one of our programs here looking at habitats, one of the program managers talks about outfitting as well. So we can build a structure, but then he says you need outfitting, which is everything that makes your house into a home here. So you'll need tables, utensils, chairs, plumbing, electrical wiring. All of these things are areas where I think you'll see additive can play a big role in there on that side. Again, like I mentioned, for polymers, or even down to the utensil side in that area.
Cool, thank you. So my thoughts on how we're going to live there, given the window, it probably takes 5 to 7 months to get there once we have enough starships to even get there. And how we're going to live, I think that in my research for this, I think that we will not be living there, because I think that in steps, the first wave of people going to Mars, for instance, will actually be controlling the robots or the drones or the boring machine. They have to build a habitat for us. So I believe, given the climate, it's probably going to be tough to live on the surface. So there are three themes that you will find during this call that the three of us talked about in preparation for this. One is about, it is a new frontier. There is microgravity. The rules have changed. And feedstock, material, raw material, the cost of flying anything out of this planet is too costly. So we have to scavenge, we have to figure out what is available out there. We have taken metallic powder from outer space back to Earth and metal 3D print that. But even for laser powder bed fusion, the melt pool would be different in outer space, given the environment. And then the third theme will be self-sustainable. How are we going to get rid of the waste? How are we going to minimize waste and reuse as much as possible? So I think I wouldn't be surprised if first frontier of people going there, the window every 2 years being able to get to Mars, is that they will deploy all the robots and all the AI robot smart to actually drill all the tunnels and drill all the caves and maybe even build domes for us, because we need sunlight. We cannot live in caves as humans. So it'll probably be a combination. They will probably build the colony, most of it, the first decade before humans actually go there. So I foresee where we're going to live, it will be built by robots before we actually arrive there. Another topic going there. So how are we actually going to survive? Let's talk about medical medicine, bio tissue that Michael touched. So thoughts on biomedical, how are we going to live and survive? Michael, you want to touch that?
Yeah, sure. Maybe just before I can come back on the last point, I have also some insights, if you don't mind, Tuan. Thanks for the huge introduction. You say everything. The rules are changing, so we need to adapt ourselves. And at the question that how do we live in space, I think the first step is to think that we need to live at the same condition that we have in Earth. In Earth, we have this atmosphere, and well, this atmosphere is protecting us. So we need to reproduce, to print our world in the new world. And you say everything printing and with microgravity and the climate, because maybe we need to reproduce it. So this is a first point, and I think technology is the answer. You say robots, 3D printing, we need technology to reproduce what we are doing here to be able to continue the exploration. And I truly believe this is the future for that. And yeah, as you said, we can use 3D printing to build houses, for instance. So I was thinking myself to make metallic parts and to fulfill with regolith. Maybe this is how I will build my house space. So well, it was just to give you some insight for the last point. So now we can switch to the new one. How do we survive in space? So this is the new topics. Can we start one?
Yeah, feel free to touch that on tissue and medical. That is the question.
Yeah, thanks. Well, actually, we need to know that we are already using 3D printing for medicine, for prostheses, so stuff like this. So that's mean medicine is already helped by 3D printing. But coming back to what I said before, for organic stuff, maybe 3D printing could be useful printing muscles, skin, for instance. So this is how I think additive manufacturing can help for medicine in space, printing tissues, medicines. This is my insight for this topic.
Thank you. So my take on how we're actually going to take care of ourselves is there's been a lot of development, especially at the Wake Forest here on Earth, doing tissue printing, trying to 3D print a liver and heart valves and other things that could be printed, and tissue, skin, burns. We have to have, initially we don't have all this that we have here on Earth from a medical point of view. So using 3D printing, as much as we can replenish and repair, will be needed. But I don't see any short term for replacing hearts or printing a liver in outer space anytime soon. I think we still have a lot of work in terms of the medical side of it. Let's switch topic to regarding food and meat. Let me kick that off first. I've been tracking the industry for quite a while, and I share that openly on LinkedIn. And I'm very excited about what's going on both on the food side and also on the meat side, that we are using plant-based material that we're able to even print a steak. Whether it tastes the same as a outlaw ribeye, I don't know, but I see a lot of progress and desire to print food. For instance, Plantish is printing a salmon that has the same protein that looks like a real salmon, but no fish got hurt in the process. So I'm encouraged about what's going on in food 3D printing. We only print what we need, what we're going to eat. So I'm encouraged about that in terms of reducing waste. Anyone want to add to that? I do want to add one point to the medical side. What has also been worked on is also 3D printing pills, medical pills, vitamins, whatever you need. And as you know, once we're in the new frontier, just like in the old days when we went to the Wild Wild West, that we don't have all these pharmaceuticals, big factory producing all these pills for us. So I'm encouraged that our people in situ, in process, print exactly what we need and create the pill via 3D printing. So I'm encouraged about that. Clothing, I think we're far away. I don't want to spend too much time on that because a lot of the fashion, the clothing, what we're gonna wear is not 3D printing. We might print a midsole and all that, but that's not going to be a spacesuit or helmet. So I think there's still a lot of work to be done on the clothing side. Let's talk about the second theme. Well, it's great we can have 3D printing technologies, but if we don't have the raw material, how are we going to print? So let's talk about raw material feedstock in outer space. Chris, you want to take that first?
Sure. And so when I think about raw materials here, I guess there's kind of several levels coming up from bringing it from Earth being the obvious one, bringing everything you're going to use, but that's expensive to get out of the gravity well and takes a long time as well. So then you get into other areas. I think in the mid-range is maybe recycling. So using materials that you brought with you, spent elements for landers or other things like this can provide some amount of feedstock to get in and use for raw materials. That's kind of highly processed feedstock as well from Earth with the energy put into it. And then I think at the far extreme, you have the in situ resource utilization. So we refer to it as, so we'll be using the materials that we find on site on that side. And I think I saw in one of the questions talking about, what kind of minerals and materials are there available. And so that's a bit of an open question. We have on the lunar surface, we have Apollo data from the landings there that brought back samples as well. And generally speaking, you have largely oxides, so you have oxygen availability, and that's where we focus a lot of in situ resource utilization, is ripping off oxygen off of oxides to generate the oxygen that we all need to live and move there. So while it's not additive, what it does though is then that's taken a lot of the energy out of the bonds. So a lot of those oxides are aluminum and silicon that remain from the Apollo missions on there. And so those are some key elements here, similar on Earth. If you look at the history and geology of the moon on the theories, there's, that makes sense. But there's aluminum, so we can make a lot of things from aluminum, certainly on that side. So then you get into the processing side of that, which is energy intensive and requires infrastructure. And also I think that's the areas you'll kind of see early on, is a lot of power and a lot of processing plants for materials on there. And I'll say, as well, silicon you have in there. Well, silicon, getting out there longer term can be used to make photovoltaics for sure. That's the primary component in there. And that may lead into the last part. That's not the only thing you need for photovoltaics. You need dopants. So kind of the last part is the mixed model, where you're using some in situ, but you're bringing other elements that you need to make even more advanced materials on site from Earth. So you might, bring dopants or other for silicon dioxide, or alloying elements to make even more specific forms of aluminum alloys on that side. And then of course there's polymers as well. So that's the metal side. So you can work if you have a source of carbon like Mars, or if you bring carbon with you. So we create carbon, or we can bring it. But to tie into the food side, most of the food we eat is organic, and so you have a source of carbon in waste from humans even. So it's not too far out there. We're supposed to be out there to consider using carbon in there to then make polymers and combine that with other elements and other things we bring on that side. I think like I mentioned, power consideration, that's going to be a big driver in all of that, because a lot of that involves taking energy out and reforming into materials on that side. I'll just end the motto in the in-space manufacturing project here at NASA is make it, don't take it, which I think is an excellent motto here. So that's what we're looking at in the additive side.
Anything you want to add, Michael?
Yeah, sure. I mean, basically the same. I think we will need to use regolith. This is it will be a key point. For regolith, looking about 3D printing, we need to remove oxygen, nitrogen, silicon to be able to use it with the actual methods. So, well, we need to modify regolith. Either we can develop a new method based on what we can find in situ, as you were saying, Chris. So I think this is both way: improve technology and be able to use what we can find directly on Mars, for instance. The second point, talking about 3D printing, we will need wires. So maybe we can crush all the metallic parts that we can find and to extrude to use it as wire, for new wire. For powder, it looks like complicated. We need atomization system. And at this moment, I mean, short-term vision seems complicated to use it. So, well, this is my insight for this topic.
Thank you, Michael. Can you please mute when you're not speaking to keep the audio? So my take on this, very high level, I would say, in my 19 years in 3D printing, I'm being very rough and simplistic in this way. Essentially, what most manufacturers have done for decades is actually having some kind of material and then reshaping it using energy, light, curing, post-processing to reshape it. But I think what the new frontier will be, given that not the same material will be available in outer space, it is a new frontier, that there has been study and research in actually, instead of just reshaping a certain material, can we create, by mixing different available material, and create the final material with the properties that we want. So I'm talking about in situ 3D printing. And there's very little of that going on right now, but that is probably where we need to be, where we might not have all the components of feedstock that we used to here on Earth. But can we take what is available and blend those and print those on demand using whatever energy we might have? And solar is definitely an energy. Luckily for certain, the E-beam does operate in vacuum, and there's a lot of vacuum out there. That leads me to the first theme, which is probably the most important theme, in my opinion, is the new frontier with zero gravity or microgravity. This changes everything. 3D printing is not ready. Most of the 3D printing technology would, unless it is modified, will really not be usable in outer space. Chris, maybe you want to share some thoughts on the impact and the challenges you see with in the new frontier with microgravity.
For sure. I think, this topic is one of the areas that's the biggest challenges, and in that sense also makes it most interesting to work here. So we have these systems on Earth that have really advanced in the last decade on metallics, and even longer than that on polymer side. And now we have to use them with either zero gravity for in space or reduced gravity of differing amounts on Mars and lunar surface on that side. And down at the physics level, you get down into convection and the way joining processes, a lot of these are melting processes. So the way those form and cool and form grains. And it's a really interesting topic that we know is going to produce different results in space here than on Earth. Some of the other panels earlier today were talking about the modeling and simulation on that side and how our physics-based models have really advanced. And I think that's a key area on Earth-based applications, but it's going to be even more important as we try and understand this for in space. we'll be doing experiments along the way, but we don't have the, hundreds of years experience with manufacturing at gravity 1G that we have here on Earth. So we have to be smart in how we apply these models and the experiments to try and vector us into the right important areas on the way here, for sure. And then the other area I'd touch on that side on, environments for us on Earth. I think we talk about in additive side, it makes sense often when you're making complex parts or when you're making things in specific environments and that may require custom alloys and all. We were talking materials and alloys in the last section. The processes can be modified and work with alloys and work with what we have. But I think the other part of this is the certification story. And so we talked for aviation earlier in one of the panels here, the panelists were talking. A lot of that is experimental here and requires NDE and hands-on and touch work, and that will get very expensive and sometimes impossible to do in space on here. So one of the areas I think additive, which is by its nature, kind of a digital and automated process, and we create these histories of it, can we get to the point where we can understand that and use that to certify and know with our combination of modeling and understanding that these parts are going to be good for use, initially in lower risk areas, just like on the commercial aviation side, but then eventually for human occupation on that side. And I think the answer is yes, but those are areas that are kind of interesting and need a lot of study on this side. So I think that's another use case for additive here, is when you're manufacturing thousands of miles from the surface of the Earth, as well as another use case because of its nature.
Thank you. Anything you want to add, Michael?
Yeah, sure. Well, I completely join your change everything as you said. Just the first remind that all the physics that we use on Earth, when you check the formula, the mathematical formula is using gravity. So if you change gravity, you change the rules. So this is a huge first point. For 3D printing, I mean, of course, they will have differences. The first point is that we don't have any more convection. So that's when we just, as you said, have conduction and radiation for thermal cooling, for instance. So this is one huge first impact that we can consider. The shaping will be not the same because the shape is impacted by the gravity. So we change the shape and the geometry of the stuff. And for instance, when we have a fusion pool, like in parallel bed fusion, we will change the shape of the pool. So it's changing everything, changing the rules. For powder, this is another issue for 3D printing, but we can guess maybe to reproduce gravity. Maybe it's an answer to that, to this microgravity. Maybe we can think with centrifugal systems to reproduce kind of gravity on some devices to keep using at the same level at Earth.
Thank you. I think overall, a very high level, anything with powder base or liquid base, it's going to have some serious challenges. So it seems like anything that's wire fed, wire welding using some kind of energy source, the most probable and initial way of producing, because as we live there and sleep and eat there, we also need to be able to create things. We do need a factory and whatever material we have. And a lot of material we don't know yet because we're not out there amongst the stars and looking at what is available of material. So we have to leverage what we have. But when we talk about the new frontier, it sounds to me like to infinity and beyond, it is a new frontier and there are opportunities. Is it first come, first serve? Is it whoever gets there out first? Is it the first one who find a planet filled with diamonds and take those back home and change the game for cost per carat? I don't know, but let's talk about, are we talking about a potential new gold rush, the space gold rush in the new frontier, and relating to that about self-sustainability? Chris, you want to take that first?
Sure. And, I think the first thing when I think about this is thinking of disruptive economies. They're not usually predictable here. So you definitely won't hear me say that it can't happen here for sure. Do we know exactly what they'll be? I don't know that we know that necessarily right now either. And so part of, you've heard me mention some of our work is focused on infrastructure. So NASA to enable lunar economies and low Earth orbit economies. And so we want to be kind of early customers in there, but we don't want to be the only customers going forward. So we want to enable infrastructure that other people can build off of and work up their own business plans and business ideas and leverage that for the benefit of mankind and the benefit of the economy here at home on that side. You know, if I look at some potential routes here, if you look, you know, I think tourism is probably an obvious one right now where you see interest in low Earth orbit or suborbital flights. Even on that side, I imagine there will be some interest for lunar and Martian down the road as things grow on that side. So that's maybe one obvious driver. And like you said earlier, you know, our habitats, we don't want to live in the caves for sure. So I agree on the windows. And so we need the smart people here working on how we generate additive clear structures. The big dome, like in sci-fi, would be fantastic on that side, and probably help on the tourism and gold rush side on that. Kind of other areas where, you know, I see us growing is future off-Earth production. You know, I think you can read the news and you see people that talk about putting manufacturing in space and moving things that pollute off of Earth so that we can, you know, try and help affect climate change, their activities here. And NASA has programs looking at in-space production applications. So in space for Earth, where we can make custom things that are, you know, flaw-free, that can be brought back down, or longer term, like I said, move that pollution outside and address some of our longer term issues as well. And, you know, I think as we develop and learn things also, I think part of the benefit as well is in thinking about what we're going to use and recycling it and the materials that we're going to use. In some sense, to me, being forced to think up the whole life cycle for parts and being limited will help us be more efficient. And that could have spin-offs here at home as well that will help us on the economic side. So technologies that enable us to do interplanetary exploration might enable us to make cheaper things that are less environmentally impactful at home also.
Thanks, Chris. Anything you want to add, Michael? What are your thoughts?
Yeah, thanks, Chris, for all this information. Nothing really more to add on this topic. I think it's obvious. It will be a new world. I mean, new resources. Yeah, it's for sure it's a gold rush. So it's part of the humanity. We need to grow up. We need to colonize our fields. So of course there is a appetite going to the space. So yeah, really, I think it will be a gold rush for space. And I think technology will be the passport for that. So better we will be, guys, doing everything, sooner we will be in the space. I think this is the point.
Thanks, Michael. My take on this is, it is the new frontier, and there will be opportunities. So no risk, no reward. Like Buzz Lightyear, you gotta be brave. You gotta just do it. And we'll space immigrants. We will have the pioneers. And it's not gonna be like your Four Seasons. It's gonna be tough for the first immigrants, the first Martians. Luckily for us on this planet, we have some visionary billionaires who are ambitious, and the way they look at things is, in less than 30 years, we will have a colony on Mars. And we will coexist with robots, because somebody has to clean the windows, because those 20, 30 kilometers, the moon super dust storm, somebody has to clean it up. So the way we live and eat and work is going to be different. And a lot of the boring stuff will be outsourced to robots. So, and we will have cyborgs. So it's going to be the wild, wild west. Somebody has to regulate it. Somebody has to police it. But hopefully the UN or the Space UN will have some regulations so that it's not like the wild, wild west. As promised, I want to leave about 10 minutes for our audience to ask questions. So to my panelists, the first question goes to you. Chris, do you want to take that one?
at the top of the list here. So question me, NASA's several times before, how different are its properties compared to powders found on Earth. So I'm not a geophysicist expert on here, but I have, done some of the research on this side, but I'll maybe point to future work in the end of this. As I mentioned before, it's largely composed of aluminum oxides and silicon oxides and silicates in here. Those being some of the three biggest components on the lunar soil. On Mars, we believe there's plenty of iron content as well, contributing to the reddish color. But when I say we believe, I guess that's really kind of the point on this side. There are, in the planetary sciences side, there are ongoing missions and plans to further characterize and all of it, and that feeds into planning and how we get there and how we do living and how we make things. Part of that early work is to understand exactly what is there, and I think, Tuan, you were referencing that earlier on that side. We have to know what's there to know what we can make out of that material in the planning phases here. And so that's of interest to NASA, kind of the overlap area for planetary sciences, from our science mission directorate over to space technology mission director and exploration systems development mission directorate on that side. So a lot of fun, exciting research on that side there as well. And then, maybe just a little bit more, how are its properties compared to powders found on Earth? Mechanically, I think it's similar to rocks you'd find here, basaltic rocks in some regions. But one of the things is there's no erosion. So I think one of the things we found out from Apollo is it's sharp and abrasive. And that's an area for our materials and understanding as we build things and as we use the robots and cyborgs, Tuan, as well. They have to be dust resistant, and working the tribology and the friction and sealing and keeping all the dust out is a kind of a critical area there as well.
Thanks, Chris. The second question goes to, could some of the materials found on other planets, soil, dirt, be transformed into parts with AM? We touched a little bit on this. It's not like today NASA has gathered samples, as you alluded to, but we don't know what we don't know. We're not exactly jumping between planets right now, or meteor, or whatever else we can excavate. I think a lot of the unknown is we don't know what else is available out there. But even if we find it, we have to process it to some form before we can actually use additive. So another way of answering this question, we are humans. We will look at what's available and make the most out of it, and we will create systems that can use that material or feedstock to create something with that. That's why we are the ruling species on this planet. So if you are a material scientist, you might find yourself in high demand, becoming amongst the earlier Martians, because we need to figure out what to do, because we cannot rely on Earth to ship everything up. It just doesn't make sense. So that will create a new way of thinking. The space immigrants, the Martians, they will be a different kind of people. They will not be relying on Earth, and they will have tough times, but they will have raw material that we might not even know about here on Earth. So just like the first people who went to go west in America, they had the gold rush. So could there be other kind of gold rush? That is very possible. We touch on the question about microgravity. Another way I want to touch on this topic is, if we look at the last 37, 38 years, if you think about it, the way we have designed most 3D printers today, I now have worked for 8 of those, is they are actually human operated. You need a human. That's not going to fly on Mars, on other planets, because as I mentioned to you, the first wave will mainly be robots, smart robots, who will be operating all this. So there's a lot of work to be done. I can only think of Inkbit, who have used additive with eyes and brains, meaning embedded in situ vision and machine learning. And I think this is, we need more manufacturers to think about that. Not only the printing side to be automated, less dependent on a human. We can control it remotely from Earth, but if ideally, can you have a machine that can self-learn, learn faster, and run the machine beyond the printing to really control the material property? More importantly, that is really not been talked about enough in this industry is about post-processing. Because if you don't control that, you won't have the desired repeatable material property. Anything you want to add to Michael, or Chris, you want to add to how 3D printing needs to evolve to add value in outer space?
Well, I think you say the two key points. I mean, looking what we can do at the short term, we need to use regolith, so we need to handle this material. Said it during the panel, but we need to remove some element, oxygen, silicon, to make it printable. So this is the first step. Medium term will be to use material that we can find in situ, as you said. Last point, and you're right, we need to think about how to be sure. I mean, 3D printing should be something normal. Check about quality, about everything, post-processes. It should be something automatic, easier. So we need to improve on this way, because now, as you say, part of this industry is on the post-process and the control that we are making to do. If we manage to make it automatic and with quality, we can just forget about that and keep our brain just for print. So I think I agree with your position.
Yeah, absolutely. I think you both hit it on the head on that side. Juan, when you mentioned having it, being feedback controlled and using artificial intelligence, I think that's the direction we have to go. In one of the panels earlier today, they were talking about how they have the shop, and right now the 3D printers run 24/7, and the bottleneck is on machining and post-processing. And that's an area where we still do a lot of work on that side, is post-processing, and that's manual, including the machining, build plate removal, and all of that. So all that has to eventually further evolve where we can eliminate that and not have the humans in the loop so much on there, for sure. The application of it, I think one of the questions below, kind of in this thread as well, is why is it there? I think we touched on some of that, and in this topic as well, if it's the automation and digitization and the record on it, these are areas again where the huge advantages for additive manufacturing to stretch them from where they are, kind of less touch labor already, but then taking it to the extreme. So fully agree on this one.
Exciting. Just for fun, Chris and Michael, would you want to live on Mars?
My wife won't let me live on Mars.
I'm ready, guys. I'm ready to go there.
It would be exciting for sure.
Looking forward. I mean,
it was a leading question because a billionaire said he wants to go to Mars, but and he want to die on Mars, but not on impact. That leads me a little bit on in closing to wrap things up. It is to infinity and beyond. Anything is possible. If you want to know what the future can be, it's no secret. I'm a big fan of Elon Musk. I think in preparation for this panel, and also I do share infographics. One that is almost called Musk City, because if you decode all the companies that he's involved with, and after Tesla, he's gonna make a iRobot. He's gonna make a smart robot to do the weird stuff. So if you think about it, humor me a little bit. It is not impossible that the direction that Elon Musk is going with, if you think about it, the Boring company would dig all the tunnels. The Hyperloop is to interconnect us between the caves. Somebody has to clean all the solar panels. That's why you have Solar City. Somebody has to clean them. That's why you have the robot. Somebody have to take care of the people. That's why you have the robots. We need to capture and store all the energy, limited energy, because we are somewhat, most of the time, not most of the time, but often covered by the moon dust, a dust storm. So whatever we can capture of energy, that's how we have the power wall. We have to store the material, and interfacing with controlling the robots. That's why you have Neuralink. So if you decode all the companies that Elon Musk is doing, actually he is preparing for a civilization, a true Martian community. Thank you.